Hi, I'm DJ Ware. On this episode of the Cyber Gizmo, I'm going to be looking at, well, some other YouTubers have looked at this, and I thought, well, I'll update it and try to pick some choices of my own. But there's a number of people that are replacing Linux commands with commands written in Rust. And I thought, well, this might be a good opportunity to take a look at some of those, see how well they are doing. And of course, you know me, I'm going to test it against the originals to see how well they perform. Let's get started right after this. Okay, so I have installed all of these commands already. So the first one we want to look at is Atuin. And Atuin comes up with an up arrow press. That's all you have to do. And then it will display your, as you can see, yes, I've been running through a lot of these commands today. So yeah, I mean, you can pick up whichever one of these you want and run it. So let's see. Let me find one here that's kind of innocuous. So let's say I want that one, and I just hit enter. It drops me to the command line and inputs the command that I was wanting to run. And let's see what we get here. So I'm just going to list out through all the directories and get that. And the next time I hit up arrow, you'll notice that that is the one that it has there. And then if I don't want this, I can just hit escape to get out of it. So it isn't that hard to install. I am using this under Z shell, and yeah, it isn't too difficult to install at all. So the next one we want to take a look at is bat. Now you'll notice that let me see if I can find something here. So let's see, cat looks something like this, where it just is a simple list. But bat, in fact, here, let's just do this. There we go. And bat kind of organizes things a little bit better. So you have line numbers, and so you might as well do this one as well. So there's you can concatenate files together just like you could with the cat command, and number all the output lines. You can highlight a JSON file or list languages. Let's see what that one does. So here's the ones that understands. That's pretty, yeah, that's pretty good. So if I had, let's give it a try. So yeah, it gives the highlights for that particular language, which is C in this case. So that's pretty nice. Oh, it doesn't know how to go to the next file. So that's not good. But so did it lump them together? Is that what it did? Let's just go through them. Yep, it just runs them as a list, concatenated list, which is fine, I guess. That's fine. So the next one I want to take a look at is bottom. And bottom allows me to bring up kind of a snapshot of the performance of the system. So it's a graphical representation. There's not a lot going on here. So yeah, there's no temperature sensors found on this machine. This is Asahi. So that's bottom. Okay, so let's try difftastic. All right, we'll do a help on it then. All right, so let's compare it. So this is the old way of doing it. And you notice that it doesn't really tell me what I have to guess, right? I got to go look at it and go, ooh, let's see what's different. I know that there's a difference between them, but it's not obvious on what part of the line it's different, right? So let's see what difftastic does with this. So it shows me exactly what's different. Install versus run. So that's nice. That's really nice. That finally, that's a big improvement over the old diff command. I mean, personally, I think the old diff command was pretty much useless. The next one we want to look at today is dog. Let's do and see what we have here for our examples. Looks up the IP, looks at the MX record. Let's see what we get. So that must be this must be the refresh time on when the DNS recaches. Let's see if it'll do a reverse. Yeah, see there's a root server here for them. The next one we want to look at is so let's look at the original DU. And DU will show you, well, you can do so we can get a kind of a, yeah, I've got one there, apparently is owned by somebody else. So let's see how dust compares. So it's showing me where most of my data is. It's in that file right there. Yeah. And then it shows it kind of in a tree view, which is nice. Very nice. I think I like this output. This seems more useful to me than this. Let's do it this way, just with an H. So yeah, you can summarize by directory. Let's look at EBA. So let's try. Yeah, see it. Yeah, it uses, it has floating point. Probably have to control C out. All right, so let's look at EXA. EXA is an improved file lister. Of course, we've all seen this, and if I want to see all the files, I can do that. So let's try. There's EXA. Let's do a TLDR on. And let's see what some of my commands are here. So, okay, good. All right. So let's give, and let's see what it does with them. So in contrast, there's the ls command looks awful in comparison to this. This is showing me my owner, but not my group. I suppose there's probably a way to show the group, but by default, that LSLA shows the group. Let's see if there's a way to show the group. Yeah, okay. I just have to give it an extra command. There we go. Okay, so that's the number of characters in the file. Not bad. It's all there. I like the organization of this better than ls. I mean, this is kind of old looking. Yeah, this is definitely better as far as presentation. This finds files. This finds files. Let's see how it works. Just a pattern. All right. All I have to do is that. Yep. That's all I got to do is that. Has to do it that way. So, yeah. This one they said does not have as much of the capabilities, although it looks like they've been working on it. I mean, fine gets insane. If you, there are so many different ways of doing fines. There's the pattern search. Look for owner and base. I mean, fine can look for things like just directories. It can look for, well, now this is to find all zip files and unzip them, which of course you can do those kinds of things with fine too. There's the exec command in fine that allows you to execute, taking that file list and pushing it to something to run on it as well, so when it has a match. So yeah, okay. Let's try hyperfine. We'll just put it in by itself and see what we get. It's telling us to do more options. Let's just see what we get here. So the warm-up performs, and number of warm-ups runs before the actual benchmark. Right, fill the desk cache, and for I/O heavy programs. All right, so let's just try an example. We'll just do this one. We'll just do my directory. I've got enough files in here, I think. Okay, so the first benchmark gives me user, system time, just like time does, and it tells me 297% of the CPU. So let's see how that compares to LS. If I did this correctly, it should run them both at one after the other. Oh, didn't like it. Oh, I bet you I know why. It's probably choking on that file. It's choking on that file that's owned by somebody else. Okay, but XA was ignoring it because it can book bypass. So that's interesting. All right, so let's try that again. And I'll wrap this in a sudo so that it doesn't terminate. See if it'll actually compare the results. Yes, it did. It says that LS ran 4.28 plus or minus 0.38 times faster than EXA ran it. Yeah, it's running in milliseconds versus seconds. All right, let's try the Linux utility for listing file systems. Now this would be the same as this. So let's try LFS. Let's just try LFS. Let's see what we get. Oh, okay. So it's going to list, it's not listing, it's skipping over non-device file systems. So, okay, that's cool. And it's showing me my NFS. It's showing me my two SSDs. One's the boot, one's the root. Yeah. Not bad. Show all mount points. Let's try that. Okay, now we pick up all the rest of the stuff. This is nice. This is much nicer. Because if you run a mount command, look at this mess. And you compare it to that, that is so much nicer. The other thing it really needs is a raw output, and I don't see one, so that I can pipe this into other apps. That's one of the things these guys are forgetting about. So anyway, I like it. It looks good, other than not being able to use it in a pipe. All right, so I have installed Procs. Let's see where it put it. Is it Procs, P-R-O-C-K, or P-R-O-C-S, there it is. Okay, so there's my PID. Let's see if we got help. We do. So page up and page down works. So the pattern search works pretty well. And comparing it to this, yeah, I don't think there's much comparison there. Yeah, I like Procs. I like it a lot. Okay, so I won't put this through its paces, but let's just see. So now I would do normally, if I was looking for, let's say I was looking for phonics, right? So I would run that. There we go. So let's see how ripgrep handles this. It's RP, I think it's RG. Yeah, RG. And let's see, let's try phonics. Let's first try it in that. Nice, it highlights where the match is. And if I do it, it goes all the way down through it. I noticed that it is skipping directories, which is good because it's only searching files. It's probably only searching, and again, it's showing me all the instances here. This is very good. We've been kind of doing this one all day. This is the tealdeer, which is tealdeer. So we've been kind of running this one, and this is also written in Rust. Yeah, I mean, if you compare it to, oh, there's no man entry. Oh, so I guess in their case, all they're doing is this one. So let's see, I could probably do it that way. Okay, so the next one we want to do is we want to look at tokei. And so for this one, I'm actually going to go into the byte benchmark. And we'll go into the source directory. Okay, so this is what we want to find out. Now, this does not have anything other than C in it. And I think it'll show me which is a header. Yeah, all right, so let's go out here and let's just run it out here all by itself and let it run down through everything, which, yeah, doesn't help much, really. But it does identify the file. It says this is the number of files that it found, the number of lines of code, number of lines in the file, period. In other words, how many carriage returns did it have? Then my code, and then what it thought was comments and what it thought were blank lines, which is good. I mean, I would love to. Well, I guess I could bring down the source code for. All right, so let's go out here, and the latest stable we have is 6010. Yeah, let's bring down a tarball. And we'll do a count on the latest 6010 release. It's going to put this in Linux. Okay. I shouldn't have put it in the names, but oh well. Too late now. It'll be done by the time I stop it. All right, so let's try tokei from out here. Okay, so how many lines do we now have in Linux? So code is the only thing we're interested in, so about 26 million. Yeah, 26 million lines of code. 34 million lines. Yeah, and we should start seeing Rust. I know there's a number of people that are starting to write. Maybe it's in 6.1. Okay, back to tokei. So I want to see on 6.1 if we have any Rust code showing up yet in the kernel. And yes, we do. We already have 4,876 lines of code. Nice. So yeah, it is starting to show up in the in the Linux kernel, which I know they've just recently started to allow that, allow people to write in Rust if they want to. And it looks like some people want to, which is very good. So that's the list of the ones I have today. I thought it was kind of interesting in trying to run, as you noticed, trying to run some of the comparisons between the older C-level commands versus the new Rust. Now, it's not fair to really benchmark the two together because the Rust versions are bringing additional functionality. They're prettier. I think the information, for the most part, is better organized than it was in the past. So yeah, I mean, I'm all for improvement. I'm not stuck in my ways and going, oh, I just want to use LS or something like Mail or Mail X. I'm not that way at all. So I'm kind of glad to see that somebody has taken the time to start to rewrite some of this old stuff and adding new improvements to it. Hey, that's how things move forward, right? I mean, that's what we want. We want things to move forward. It doesn't have to be faster. It doesn't. It just needs to be better. Give us better information, more control over our systems. That's what those utilities were all designed to do. And, you know, they're showing their age, and I'm very glad that they're looking at it. Yeah, it's been a long time coming. Yep, it's been a long time coming. The one thing that I would really be cautious about, though, is I don't know how much these guys are paying attention to the ability to string commands together. I mean, the reason why some of those older commands generated the output that they did was to allow them to be strung together with other commands. I noticed in one case where they were actually replacing what would have normally have been a combination of a Linux command with a sort. So yeah, I mean, that's fine, but just remember that when you're replacing these things, you want to be able to have you want to maintain that ability to be able to pipe things together and form longer strings or longer commands that will do more with it. That was the strength of Unix to begin with, and it's still, I feel, a strength of Linux, even though most of you all are on the desktop version of Linux are not using the command line. I think you're missing out because there is a lot of power under the hood if you choose to do so. Anyway, that's all I had today. Hope you enjoyed this video. If you did, please like and subscribe. Hope to see you all again in the future, and bye for now.